In this video, let me start from how does the interparticle spacing differ in three states of a matter. So till now we have studied about the three states of matter, which are solid, liquid, gases here. Okay, so in these matters, the space between the particles, how it is differ, that we are going to discuss here now. Okay, what role does the interparticle spacing play in determining the properties of each state, that is solid, liquid, gases? So what they're asking here, if the space between the particle, if it is changing, why it is changing the properties of these matters also here. Okay, and how it is changing, that we are going to study here. For that, let us perform the following activities to find out the answer to these questions here. Okay, so that we are going to understand by activity 7.6 here. Okay, now take a syringe without a needle. Here we have to take a syringe and we have to remove the needle here. Pull the plunger of the syringe outwards in the fully extended position. So we need to pull it outside. So we have to pull it completely outside, like, okay, fully extended position. Now place your thumb over open end of the syringe to prevent. So once we done with the extended of this position, we have to cover this side will be open side, so we have to cover with the help of the thumb here. Okay, now push the plunger slowly and steadily inwards. Once we cover with the thumb, we need to start push to the inside. Now we need to start pushing inside here. Now from this activity, what do we observe here? As you do this, you'll notice that the volume of air inside the syringe decreases. So when we pulled towards outside, no, it was completely filled with what? Gases here, or we can say air here. Now when we covered here with the thumb, again still we are pushing it inside, but there is no place to escape for the air, but still it is what it is happening, the space is getting decreases. So still it is decreases, means what is happening with it here, particles of gases here, or we can say air here. Okay, what can we say about the behavior of this gas in the syringe? Okay, now when you compress the air by pushing the plunger, the particles are forced to come closer. Now here it is, particles are very far from each other in the air, as we know that. So when we will start pushing the plunger inside, so what will happen, the particles, it will come closer here. Okay, this shows that the gas particles have a lots of space between them in their natural state. So from this we can say that in the natural state of air, there will be a lots of gap between the particles. Okay, so when we will start pushing inside in the case of syringe, now particles, it will start coming closer. So from this we can say that the space between the particles is very far. Okay, this shows that the gas particles have a lots of space between them in their natural state. Okay, and this space can be reduced by applying a external pressure like this. So here we have applying the external pressure, that we are pushing inside, so that we will say external pressure here. So by applying the external pressure, what we can say, we can bring the particles of in air, we can bring it near to them. Okay, now if you stop pushing the plunger, the gas particles spread and the plunger moves back to its again original position. Repeat this activity using the water, and what you observe here, you would observe that water is practically incompressible. We cannot compress the water. Okay, now let us perform another activity to learn about the interparticle spaces in the liquid here. Okay, activity 7.7, let us observe. Take a glass vessel here like this, fill it about half with the water. Okay, now and mark the level of water. So here in this here water is up to here, so we have to mark with the A here. Now add 2 teaspoons of sugar into it. So we have to add 2 teaspoons of sugar to this vessel here. Now mark the new level on the glass vessel B here. So after adding of the sugar, the water level, it has been raised little. Okay, so here it is the mark B. So earlier it was the level A, and here it has been raised to B now. Okay, after addition of the sugar here. Now stir the water with the glass rod. So this is what glass rod, it is completely made up of what, glass in the shape of rod, so we will say glass rod. Now stir means we have to mix the sugar with the water very well, that they are saying stir the water with the glass rod to dissolve the sugar. So once you started stirring, sugar, it will start dissolving in the water. Now predict whether the water level will increase or decrease with the respect to the mark B. So is it going to increase or decrease of the mark B after dissolving the sugar? Now mark this water level again as the C here, as you can see in the picture. What difference do you observe in the water level now here? Because the water level has been marked A, B, C. So as you can see in the picture, C has been showing with the under the of the B. Okay, it means from this we can say that the water level what it was there no earlier from the B, it has been decreased little bit, right? We'll see what is the answer here. You'll observe that initially when sugar is added, the level of water has increased from A to B, correct? Okay. Now but after dissolution is nothing but after dissolving of the sugar here, it may decrease to some extent. Some extent means it is not going to differ very much. For little it is going to decrease from level B to another level that we have marked here, C here. Okay, since the volume of solution is less than the sum of the volume of the water and sugar. So here in this sentence, since the volume of the solution, which solution? After dissolving of sugar in the water, that is solution. So this solution is what they are saying is less than sum of the volume and water, volumes of water and sugar. Sum is what? That is only water plus sugar here. So compared to this, this solution, I mean after dissolving of sugar in this solution, this volume is less than compared to this one here. Okay, now it indicates that there is some space between the water particles. How it is indicating? Because the volume has been decreased. Okay, so it indicates that there must be some space between the even the water particles, right? Water particles. The particles of the dissolved substance occupy these spaces. So here, now this is blue color, it has been shown, that is water particles here. Now as you can see here, there is a space between the water particles. And yellow color particle, which is what? Sugar particle here. After dissolving means what is happening? Sugar has been break down into the smaller particles, that we will say constituent particles. So these constituent particles, what it will know, wherever it will get the space between the water, no, it will go and it will occupy that space here. Okay, that only it is showing here. Now repeat the activity 7.7 with the some other soluble solids such as common salt or glucose, and insoluble salt like sand and stone pieces also here. What do you observe in each case? Do the sand particle dissolve? No. Does the volume of water in the vessel change after mixing, and why? Okay. So here the girl asking, sugar and sand both are solid. Yes, both are solids only. Why does sugar only dissolves in water, but why not with the sand here? Okay, now answer to these questions I will upload in the next video. Okay, thank you.